Hello, my dear students. This is RV Jambagi welcoming you all for 9th standard online classes. I hope you are all well under the situation of COVID 19. Let us move to the today's lecture, that is on motion. Dear students, I am introducing the new chapter, that is motion. In the previous years, you learned many things about the motion, such as rest, motion, and their types, maybe the differences between rest and motion, distance, speed, time, acceleration, etc. Here in 9th standard, you are learning detailed study on motion. Before moving to the main part, let me explain the discussing points of the chapter in brief. Here I am introducing the term called mechanics as a main branch of physics. I am introducing the term mechanics as the main branch of physics. Even though it is not there in your syllabus, it's my duty to give you the information where exactly you are learning the motion. You have the right to know where exactly you are learning. Okay. You are also learning one of the branch of mechanics, that is kinematics, where you are learning rest and motion again, types of motion, various types of motion. You are also learning the part called scalars and vectors. They are very much important in understanding various aspects in physics. You are also learning some terms related to motion, as such distance and displacement you are already aware, I believe. Speed and velocity, acceleration. After all getting those terms right, we are moving to the next part, that is graphical representation of motion, where you are exactly learning distance or displacement time graph, velocity time graph. Using that concept of graphical method or representation of motion, you are deriving the kinematic equations of motion, and you are getting the same equations of motion under the influence of gravity or gravitational force. There is a small portion that is known as uniform circular motion. You are also learning that. And the chapter finishes after solving problems on motion. So these are the points which you are going to study this year. Students, in the previous chapter, you had the definition of physics, which is given by the branch of science that deals with matter, energy, and their relations. I missed to give the different branches of physics, major branches of physics. They are classical physics, relativistic physics, and quantum physics. There are so many branches present in physics, but the major branches are classical physics, relativistic physics, and quantum physics. Classical physics, again, it is grouped into three, that is classical mechanics, electromagnetism, thermodynamics, and statistical mechanics. Classical mechanics, it is already there. You already begin with the classical mechanics. It is oftenly taken as Newtonian mechanics. And in the upcoming years, you are going to study electromagnetism, thermodynamics, and statistical mechanics in PU level. The relativistic physics comprises of the theory of relativity given by Albert Einstein. Quantum physics deals with quantum mechanics, quantum statistics, quantum electrodynamics, and quantum field theory. These are all the main branches of quantum physics. Relativistic physics and quantum physics both are very strong subjects. So you have a lot of time to understand such things. So before understanding the relativistic and quantum physics, it is my suggestion that please study thoroughly about the classical part of physics. Classical part of physics, that is very much important. Newtonian physics, you may call. You have to understand what exactly the Newtonian physics deals. If you are aiming to become scientists, then these two fields are very much wide open for you. Let us introduce the term called mechanics. The fundamental branch of physics that deals with behavior of the bodies or objects when subjected to force or displacements and their subsequent effects is known as mechanics. Mechanics is the fundamental branch of physics that deals with the behavior of bodies, behavior of the objects when they are subjected to force or displacements and their subsequent effects known to be as mechanics. Mechanics is widely classified into classical mechanics, relativistic mechanics, and quantum mechanics. The classical mechanics concerns with the set of physical laws. Classical mechanics concerns with the set of physical laws describing the bodies under the influence of forces. So classical mechanics concerns with the set of physical laws, group of physical laws describing the bodies or objects under the influence of forces. Under the influence of forces, how the objects behave. That is the branch of classical mechanics. Also called as Newtonian mechanics. The laws describing these mechanics are completely based on Newton's formulations, most of cases, and hence it is the name, and hence the name Newtonian mechanics. Newtonian mechanics or classical mechanics explains several phenomena such as force applied on a body, why we stick to the earth or bond to the earth, why tides form, why the lightning occurs, why a magnet attracts iron, why planets revolve around the sun. So most of phenomena were explained systematically with the help of classical mechanics. Keep in your mind that Whatever the things we are learning in classical mechanics, they are relatively smaller speeds in comparison with speed of light. And similarly, the lengths are greater than nanometer scale. We did not go beyond some value, say the speed of light or comparable to the speed of light, and we did not bother the values less than 10 to the power minus 9 or 1 nanometer. So classical mechanics has its own restrictions. It cannot go far much speed. It must not it must not having the length less than 1 nanometer like that. As this branch don't have any answers for these following questions. What is the reason for gravity? How our universe formed? It did not talk about gravitational waves, wormholes, black holes, and any other such domain. And similarly, the behaviors of atom or molecule, it did not bother about atoms and molecules and their levels at all. To get the answer or answers, to get the answers, we need the part of relativistic mechanics and we need quantum mechanics. Relativistic mechanics describe the motion of the bodies on the basis of relativity. On the basis of relativity, it is given by none other than the great Einstein, Albert Einstein, who proposed this wonderful theory called theory of relativity. On the other hand, the lengths which are below nanometer scale, we need a special part that requires quantum mechanics. Quantum mechanics actually deals the mathematical description of motion. Keep in mind, it gives the mathematical description of motion and interaction of microscopic bodies and the interactions of microscopic body on some principles. On some principles, it explains the microscopic action of the bodies, or you may call it as particles. Okay, so for the range of speeds equal to the speed of light, in that level we require relativistic mechanics. If you are having the lengths which are very much less than nanometer scale, we need quantum mechanics. It can be shown pictorially like this. So this picture confirms the role of classical mechanics, relativistic mechanics, quantum mechanics, and even quantum field theory. Keep always in mind that whatever you are learning physics at this age, it is the complete understanding of it is on the basis of classical mechanics only. So whatever you are learning at this age, that is simply classical mechanics. If you want to learn relativistic mechanics and quantum mechanics like that, you have to confirm that your basis of classical mechanics must be firm, and by that you can move towards those subjects. And to understand relativistic mechanics and quantum mechanics, I firmly believe that you have a lot of time. So my suggestion again is to that Please study the classical mechanics thoroughly. So whatever we are discussing now in 10th, in PUC and second PUC, so you must study well. By that you can understand the parts of relativistic mechanics, and later in the PG level or degree level you may come up with these subjects. I hope you are following all these points discussed. In the next period, we are going to study bit about classical mechanics, and later we'll move to the main part of motion. This ends today's lecture on introductory part of motion. Till the next class, take care of yourselves along with your family and friends. Bye bye.